Hello everyone, welcome. This course is for complete beginners, university students and aspiring competitive programmers. We use C++ because it is the standard language in competitive programming, but every concept applies equally to Python, Java, JavaScript, Rust, Go and other languages. If you prefer another language, ask an AI assistant that convert this C++ code to Python, Java and explain each line. This lets you follow the course regardless of your programming language. Okay, so let's start our topic. Imagine we have two programs. This program 1. Suppose we have two programs, program 1 and program 2. These are completely different programs. And both programs solving the same problem. One finishes in 1 second. One finishes in 1 second. The another one, suppose this solve a problem within 1 second and this take 1 hour. But both program can solve a problem. Which is better? My question is for you. Obviously, the program take less time as much as possible. That program is better. Today we will learn how to measure algorithm efficiency using time complexity and space complexity. Basically, time and space complexity allow us to pick a program that solves a problem as fast as possible. So, in time and space complexity, there is a thing or topic we can say, which topic called big O notation. So, big O notation. As this video mainly focus for competitive programming, we not need any university level or academic level explanation. We just need to learn the concept. So, this is called a big O notation. This is like a function like this way. So, we write this function in this way, O, and this is the function. This is something like in mathematics we have functions like f of x, something like that. This is a function. This tells us the time taken by a program. So, one of the fastest notation, or we can say a fastest possible method to measure an algorithm is O of 1. What is O of 1? When a program complexity is O of 1, it says that this program takes one of the lessest time possible. So, let us look at an example. So, for example, I am diving into my editor. So, I am using Sublime Text. So, suppose we have a array like this, then let us say its value is 10. So, this line of code, this in x equal 10 is it has a complexity. Its single line complexity is O of n. It takes O of n time, O of 1 time, sorry, this O of 1 time. So, if I print this and run this code, it prints something. So, it takes O of 1 time. Or this takes a constant time. So another notation of big O is O of n. What is O of n? It is a linear time complexity. So let's look at it. Suppose I wanted to find out the sum of n elements in an array. So what I have to do, let's define a variable sum 0, then let's run a simple loop. Then sum. So let's take an array also. Let's calculate the sum. So now tell me what is the complexity of it. So this program takes a linear time complexity because it visits every element once n times. So it takes operation n times. This comes here 1 time, this comes here 2 times, and until n times it runs. So let's run it. I can take a input. So I can give a 1, 2, 3, 4, 5, 15. This gives the solution in O of n times. This is very good complexity for us, but even there is a very good big O notation for us, which is O of logarithmic of n. One of the core implementation of logarithmic n, or one of the beautiful example of logarithmic n, and every competitive programmer's dream is to make his problem or solution convert to O of logarithmic of n complexity. So to do that, let's write the code of binary search. That binary search, if you don't know the binary search, please comment down below. I will make a video on binary search that's gonna help you to learn it. So when it comes to binary search, we split suppose we have a variable n, we split it by 2 times, then we split it another 2 times, then moreover we split it another 2 times. This is the main concept of O of logarithmic of n. And one of the O's complexity is O of n square. O of n square. So when we write the code for pattern printing, we do that, and it iterates each part in double n time. So we call it O of n square. These are the common notation of time complexity. Let's look back into the space complexity. Space complexity. So from this name, we understand this is all about space, the memory taken by our program. Using only a few variables is O of one space. Creating a vector A of n uses O of n extra space. So let's back into the code. Here you can see these vector take O of n space in our memory. So these are all about time and space complexity. Next episode will be C++ STL. Like, subscribe and practice before moving on. Thank you.